In this very short video, I'm going to go over how to simplify square roots. Just as a very first quick example, I'm sure most of you out there know what these square roots are equal to. So the square root of 36 is positive 6, the square root of 49 is a positive 7, the square root of 121 is a positive 11. Fine. These square roots are easy because these numbers inside the root, which we will call a radicand, are all perfect square numbers. When we take the square root, we get a whole number for an answer. When you start looking at square roots like these, you'll notice that these will not give you whole number answers. And you can easily tell that. Just type them into any calculator and you'll see that you'll get some decimals. However, within math, decimals are just approximations. And so what we want to do is we want to see if we can simplify these square roots so we can still have an exact answer. And for simplification purposes, you will need the following list of numbers. Here they are, your perfect square numbers, aka the numbers that are easily rootable. So what we do is we try to find the largest number in this list that we can make a factor of this number at each radicand. So for example, when I look at this first square root, I know I can factor 12 into two different numbers, like 1 and 12, but 1 and 12 are not in this list. So I've got to keep thinking of other ways to factor 12. So I think the most common one that comes to mind would be 4 times 3. Now I picked this pair that multiplies to 12 because 4 is in this list. Why is that important? So we can take the square root of 4. And so let's do that. We take the square root of 4 and get 2. We have to leave the 3 alone, and we leave it inside the radical, or the square root. And that's it. We have simplified that as best we can. I can no longer divide 3 or find any factors of 3, whole number factors of 3, 1 and 3 are not in this list. And so that's it. We basically do that for the rest of these here. So for example, 72, the biggest number in this list that is a factor of 72 would be 36. So here, 72 would break down into 36 times 2. That's the factor pair of 72. The square root of 36 is 6. The 2 here is still in the square root, so we leave 2 in the square root. A mistake students often make is with the square root of 72. The student may say, hey, 9 is a factor of 72, and I can split this apart into 9 times 8, and I can take the square root of the 9 and get a 3, square root of 8, and I'm done. I've simplified it all the way. That is not true. Simply because 9 is not the biggest factor in this list. We want the biggest number in this list, which in this case would be 36. All right, so let's take a look at 39. I know a couple ways I can break down 39 as far as factor pairs are concerned. I can say 1 times 39, or I can say 3 times 13. And there are all sorts of rational ways to do that, but we just want the whole numbers because those are the easiest to square root. So 1 and 39 are not in this list, 3 and 13 are not in this list. That's it. Sometimes you have a square root that is already simplified and cannot be simplified any further. Now very quickly, I've sectioned off these bottom two examples with a different color, so you know they're probably different. The difference here is we have this negative inside the square root. There. there. And the negative inside the square root, we say comes out as an I, so it would become an imaginary unit, but really what's happening is we have a square root of a -1 inside our radicand here. And the square root of -1 is what we call equal to I, which is what we call the imaginary unit. And one thing I want to make clear here is that the imaginary unit is in fact a constant, and you never solve for I. All right, so how does this work? Very much like we broke these square roots down up here. We can say, hey, the square root of -128 is the same thing as the square root of -1 times 128. So you can see, and I'm going to do it this specific just once, the -1 will come out as an I. And we still have the square root of 128. Now, that doesn't mean we get to stop. We still have to look over here at the perfect square numbers and find the largest number in this list that will be a factor of 128. So yeah, 4 is a factor of 128, but so is 16, and so is 64. And 64 is the largest factor of 128. So we can write the I is still in the front. So we have I square root of 64 times 2, which gives me, when we take the square root of the 64, that comes out front as an 8I square root of 2. And then very similarly for this last example, we have to pull out the -1 as an I, so normally you can just do this. The negative is taken out as an I. We have 147. Then we have I square root of the largest factor in this list of 147 is 49. And then you can take the square root of 49 and get 7, put it in front. I is still outside of the square root. 3 is still left in the square root. You can see it right here. And we have our final answer. So why is it important to know how to simplify square roots? I will continue that thought in the next video when I go over how to solve quadratic equations using the quadratic formula.